Before we begin, I'd like to share a quick disclaimer. The information presented in this episode is provided for educational and informational purposes only. Every project, site, jurisdiction, and building condition is unique. The concepts discussed here are intended to help you better understand architectural design, construction principles, and building science, but they should not be interpreted as project specific professional advice. Always consult the applicable building codes, manufacturer's installation requirement, and qualified licensed design professionals, engineers, contractor, or your local building authority before making any construction or design decision. And watching or listening to this episode does not establish any professional relationship with ACHLAB, LLC. Now, let's get into today's podcast. Episode Masonry Wall Reinforcements, the hidden steel that keeps masonry standing. I'm Ann, and here at ACHLAB, we believe that great architecture isn't just what people see. It's also about the details that never are noticed. Because those hidden details are often the difference between a building that lasts decades and one that begins to fail long before it should. Today we're looking inside the wall assembly to talk about the one of the most overlooked parts of masonry construction. Masonry wall reinforcement. Let's begin. When people look at brick wall or a beautiful stone facade, they usually admire the craftsmanship, that the colors or the finished appearances, but what they actually are seeing is only the outer skin. Hidden behind those finished surfaces is an entire structural system working together to resist movement, distribute load, and protect the building over time. And without proper reinforcement, even a well built masonry wall can begin developing cracks from thermal expansion, shrinkage, wind loads, or from building movement. At ACHLAB, these invisible components receive the same attention as the finished exterior because good architecture starts long before the finishes are installed. So, what exactly is masonry wall reinforcement? Great question. Simply put, it is the placement of steel within mortar joints or inside grouted masonry cell. Masonry itself performs exceptionally well under compression. However, it does not perform nearly as well in tension. Steel reinforcements transform masonry into a composite structural system capable of handling both. This provides several major advantages. First, it helps control cracking caused by temperature changes and material shrinkage. Second, it improves resistance against wind and seismic forces. And third, it creates structural continuity by distributing loads more evenly throughout the wall. And finally, it provides stronger anchorage for veneer systems and composite wall assembly. These are details that may never be seen after construction, but they work every day throughout the life of the building. Now let's talk about one of the most common forms of reinforcements, horizontal joint reinforcement. This type of reinforcement is commonly manufactured in accordance with ASTM A951. A951. It consists of steel wires embedded directly in the motor joint as the wall is being constructed. Since masonry naturally lacks tensile strength, these steel wires provide the reinforcement needed to resist movement while helping control cracking throughout the wall. There are several common configurations you will encounter. The first is truss reinforcement. This system used two longitudinal wires connected with diagonal cross wires. Because of its triangular geometry, it offers greater rigidity, increased flexural strength, making it an excellent option for many single width loaded bearing walls. Next is ladder reinforcement. Instead of diagonal wires, ladder reinforcements use straight cross members. This makes it particularly useful in composite walls, cavity walls construction where veneer ties and reinforcement need to work together efficiently. And for more complex or higher end facade systems, adjustable veneer anchors are often used. These systems accommodate construction tolerances while allowing masons to maintain perfectly aligned veneer during installation. It's one of those small details that contribute significantly to the quality of the finished building. While horizontal reinforcements control movement throughout the wall, vertical reinforcements provide much of the building structural backbone. Steel reinforcing bars, commonly called rebar, are placed inside the grouted masonry cells to increase strength where it is needed most. And one important structural element is the bond beam. Think of the bond beam like a belt wrapped around the building. It ties wall sections together while helping distribute concentrated load more evenly across the structure. Another important feature is the reinforcement pilaster. Pilasters are vertically projections built into masonry walls that function much like integrated columns. By incorporating vertical reinforcing steel and fully grouted cores, these elements provide additional lateral support for taller walls and larger structural bands. Now, let's discuss one of the most common locations for cracking. If you're curious, it is located at the doors and windows. Every opening interrupts the natural flow of structural load throughout the wall. And without proper reinforcement, stress concentrates at those corners of these openings. And over time, of course, these concentrated stresses often become visible cracks. To reduce the risk, additional reinforcement is typically installed above the door headers to transfer load around the opening. And likewise, reinforcement placed above and below window opening help reduce stress concentration near the corners. And you will also commonly see weep holes integrated into these assemblies. While there aren't structural reinforcement, they perform an equally important role by allowing moisture to drain from the wall cavity before it becomes trapped inside the assembly. Managing water is just as important as managing structural loads. Material selection is equally important because the reinforcement inside the wall must survive for decades without excessive corrosion. For interior dry environments, mill galvanized reinforcement is often sufficient. For most exterior projects, hot dip galvanized steel provides significantly greater corrosion resistance. In coastal environments or highly aggressive climates, stainless steel becomes the preferred solution. Although it carries a higher initial cost, stainless steel virtually eliminates the risk of rust jacking, which can eventually damage the surrounding mortar and masonry unit. Wire sizes can also vary depending on structural requirements. A 10 gauge wire is commonly used to lighter interior applications. 9 gauge is considered a standard choice for many projects, and with an 8 gauge provides heavier duty reinforcement. And then there's the 3/16-inch wire is reserved for demanding structural conditions requiring additional capacity. And before we wrap this up, let's cover several installation processes that are absolutely critical. First, maintain proper continuity. Reinforcement should generally overlap by at least 6 inches to ensure forces transfer effectively from one section to the next. Second, never bridge reinforcement across control joints. And here's why. Control joints are intentionally designed to allow movement, and running continuous steel through these joints defeats their purpose and often create the very cracking you're trying to prevent. And finally, ensure every piece of reinforcement is completely surrounded by motor, and any exposed voids create opportunity for moisture infiltration. And over time, corrosion can begin, eventually weakening the wall assembly from within. And these are simple details, but they have enormous long term consequences. And as we finish today's podcast episode, remember this. Great masonry isn't defined only by beautiful brickwork or perfectly laid stone. It's defined by engineering hidden beneath the surface, the reinforcement you never see, the connection hidden inside the wall, and the drainage system working quietly behind the facade. Those are the details that determine whether a building performed for generations. And at ACHLAB, we believe thoughtfully construction detail is created lasting architecture. And because of details aren't just part of the design, they become part of the building legacy. Thank you for listening, and I hope you learned something new. And if you enjoyed this episode, consider subscribing for more discussion on architecture, building science, construction details, and practical design strategies that help building perform better over time. Until next time, keep designing, keep building, and of course, and remember, I want you to keep this. The future is built in the details of possibilities. Bye!